This is problem number 2 for assessment number 8. It says, find the total area of the shaded region. And if you notice for our graph here, our shaded region slides from x values 0 to 7, and then it goes from y values 0 to 1. Now let's take a look at our two functions here. So anytime we want to find the shaded area, we want to use this knowledge, this theorem, which says if f of x is greater than or equal to g of x throughout a, b, and both are continuous, you can see both are continuous, then we want to find the area by integrating from our, in this case, this would be our x values, a to b, of the larger function minus the smaller function with respect to x. But look at our equations that we're given. Our equations are not written y equals, they're not written in a form where y is the dependent variable, right? These equations are not written y with respect to x. They're written x with respect to y. So because they're not written y with respect to x, they're written the other way where x is with respect to y, where y is the independent variable. We can't use this exactly how it's written. So what we want to do is we want to write this slightly different. So I'm going to go ahead and write that up here. So we're going to say if, and we're going to use this different, and we're going to rewrite this. So we'll say if f of y greater than or equal to g of y. Now obviously the whole continuous thing is still the same. Then a is equal to the integral, and we'll say still a to b, but in this case we'll say f of y minus g of y dy. So we're still using this formula, but we're using it now with y being the independent variable. Now, the important part to note here is, before f of x and g of x, we were talking about essentially our y values. Are our y values greater? Are our y values greater here or here? Right? Because our input was x values. So our input was x values. We're getting out y values. Now our input is y values, and our output is x values. So in this formula, the greater function we're talking about vertically. Greater. And this one we're talking about horizontal. Horizontally greater. Okay, which function is horizontally greater? Well, that would be the 7y squared function. This right side is the farthest right boundary, which is the farthest positive boundary. So 7y squared would be the farthest right side. Now, if we were doing this way, we would say obviously the upper function would be the largest. But because we are integrating and we're switching our independent and dependent variables, now we are going to use the rightmost function, which is 7y squared, as our largest function. So I hope that makes sense how this is slightly different, because our equations are written, instead of y with respect to x, are written x with respect to y. So let's go ahead and find the area. Well, in this case, we know we are going to integrate. Instead of doing the x values as our integration, we're going to do the y values, so 0 to 1. Our f of y function, so our farthest right function, the right boundary, is y, or 7y squared, minus our left boundary, which is 7y cubed, dy. When we integrate that, we add 1 to the 2, so that's 3, and divide by 3, so we get 7y cubed over 3, minus, we add 1 to this 3, we get 4, and divide by it, so minus 7y to the 4th over 4, and we're going to evaluate this from 1 to 0. When we plug in 1, we get 7, 1 cubed over 3, minus 7, 1 to the 4th over 4. And then when you plug in 0, they cancel out here in both spots, so we're going to say minus 0. This gives you 7/3 minus 7 over 4, right? 1 cubed is 1 times 7. 1 to the 4th is 1 times 7, which gives you, if I find a common denominator, which is 12, so times this by 4 over 4, so it's 28 over 12, minus, multiply this by 3 over 3, you get 21 over 12, which ends up being 7 over 12. So the area that's shaded there is 7 over 12. Now, what would have been the difference had I not done f of y minus g of y? Well, if I don't do f of y minus g of y, all that's going to do is make this a negative area. Okay, it'll be negative 7 over 12. So one way a person could have solved this is, instead of worrying about the right and left endpoints, you could just say absolute value of, and it wouldn't matter which function you put first. You could just do absolute value of whatever you get, and you would have gotten negative 7 over 12. When we take the absolute value of it, you would have gotten 7 over 12. So I hope that makes sense. We're switching, in this case, our independent and our dependent variables, which means this theorem changes slightly so that now we're integrating with respect to y.